Good morning, 9 Set 7. We're going to revise Forces 1 this week. This is a unit that we did earlier in the year in the class, and it's a good time now to go over some of these key ideas. The first lesson is all about speed and velocity, and we will also look at distance time graphs as well. This is an equation that you must memorize. This equation will not be given to you on a formula sheet in the exam, so you need to learn it. Speed equals distance over time. There's a triangle which can help you to rearrange the equation, but you must remember that D goes at the top of the triangle. Speed has the units of meters per second, distance has the units of meters, and time has the units of seconds. And you should convert to these units in most questions. These are called standard units. Speed tells us how fast something is moving. For example, a car travels at 70 miles per hour along a motorway. This means that the car will cover a distance of 70 miles in 1 hour. A cheetah has a top speed of 120 kilometers per hour. This means that a cheetah can cover a distance of 120 kilometers in 1 hour. However, a cheetah can only maintain this speed for a short time. Sound waves travel at 330 meters per second. This means that a sound will cover an amazing 330 meters in just 1 second. Here are some examples of using the equation for speed. I'm not going to go through all of them, I will just go through the first two. So in question A, it says a postman walking his route of 1 kilometer in 900 seconds, and we need to calculate the speed. So we use the formula, speed equals the distance over the time. The distance was 1 kilometer and the time was 900 seconds. So 1 kilometer divided by 900 is 0.0011 kilometers per second. You would need to divide 1 by 900. In the second question, we have a snail crawling 10 centimeters in 60 seconds. So we would divide the distance 10 by the time of 60, and the answer is 0.1666 centimeters per second. Now the tricky thing here is getting the correct units. So if we look at question A again, we can see that the distance is kilometers and the time is seconds. So the unit of speed will be kilometers per second. And you look at the second question, the distance is measured in centimeters and the time in seconds. Therefore, the speed will be centimeters per second. In these questions, we need to rearrange the formula for speed. Question 1 asks us to work out the speed. We've done this already, but just so that you know how to use the triangle, you would cover up the S, and S is equal therefore to D divided by T. This line here is the dividing line, and you can see underneath the formula S equals D divided by T. So we would divide the distance and the time to get the speed. The next question asks us, how far does a lorry move? How far is asking us to calculate the distance. So we go back to our triangle, and this time we cover up D, and we can see that D is equal to S times T. And this line here, this line is the multiply line. So we can see underneath that we have the distance equals the speed multiplied by the time. We would need to multiply this number by this number to get the distance traveled. Okay, let's look at question 3. In this question, it says, how long does it take a car to travel? How long means calculate the time. So we would look at the triangle here, we would cover up T, and we can see that distance is divided by the speed. This is the dividing line. And so our formula looks like this. Time equals distance divided by speed. So looking at these questions here, we can see that we would need to divide the distance 10 by the speed 20 to calculate the time. So it's very important that you divide the right number by the right number. So it would not be 20 divided by 10. It must be the distance 10 divided by the speed 20. Very important you get that the right way around. Okay, the next part of this lesson is about distance, time, motion graphs. And we need to learn how to interpret graphs and draw out the correct information. So what is a distance time graph? Well, look at the picture. At the top you can see it's got distance on the y-axis. So the y-axis is the vertical axis up here. That's got distances on it. And on the x-axis, the horizontal axis, you can see we've got time in seconds. So a distance time graph has distance on the y-axis and time on the x-axis. Let's have a look at these missing words so we can fill these in. A distance time graph is a graph of time taken on the x-axis plotted against distance traveled on the y-axis. The gradient, how steep the graph is, shows how fast the object is moving. So what is the gradient? The gradient is how steep this line is here. That would be very steep, that has a big gradient, and this has a very shallow gradient. Okay, going back down here again, to calculate the speed we need to measure the vertical change and divide it by the horizontal change. Right, here we have a distance time graph with 3 sections in it, and you need to know what each section of the graph means. So in the first section, which is this one here, let me highlight that. It is a straight line going upwards, and that shows an object moving at steady speed, and it's moving away from the start, moving forwards. We know it's a steady speed because it's a straight diagonal line. The next section of the graph is at the top here. I'm going to do that in a different color. Now this is a flat horizontal line, and when you see a flat horizontal line on a distance time graph, it means the object is stationary, it is not moving, and its speed would be 0. Looking at the final section of the graph, which is going down here, again it's another straight line, but this time it's going down. And that tells us that it is moving at steady speed because it's straight, it's steady speed, but it's moving back to the start again because the line is going down. So this object has a journey which has 3 sections. Okay, the red part of the graph, it's moving away at steady speed, and then it gets to a point where it stops for a while, and then it comes back to the start as the green section at steady speed. Okay, let's look at how we can calculate speed from these graphs. Okay, so here's section 1, which I'm doing in red right now. We know it's moving forward at steady speed. We're going to use the formula speed equals distance over time. So we need to know the distance traveled. Well, if we look along this y-axis, distance is here. We know that it starts at 0 and it travels all the way to 14. Okay, so if we look here, we can see that it travels a distance of 14 kilometers. So we're going to write in the equation distance of 14 on the top. Now, how long did it take to do 14 kilometers? Well, we can draw another dotted line down here, and we can see that it took 1.5 hours, 1.5 hours to do that journey of 14. So we put 1.5 underneath, and if you divide 14 by 1.5, you get 9.333 recurring, but we can just put a dot there, and it's kilometers per hour. Okay, let's have a look at section 2. Now we know that in section 2, here it is, at the top it's flat, and as I explained already, that means it's not moving, it's stationary, therefore the speed is 0. It remained stationary for half an hour, for 30 minutes, because that's 1.5, and that's 2, so half an hour, and this time is measured in hours. Okay, let's move to section 3. Section 3 is down here. Okay, I'm going to just go over that quickly in green. Now we know that it starts at 14 up here, and it comes back down to 0. So the distance is 14 kilometers. How long did it take to travel? Well, let's draw a dotted line down here. Okay, so we can see that it started at 2 hours, started at 2, and it got back to 0 at 3, so that took 1 hour. So that's why we put 1 at the bottom here. Okay, and 14 divided by 1 is 14, and the units are kilometers per hour. Kilometers are here, hours are here, so this speed will be measured in kilometers per hour. Okay, here's a more complicated journey. This journey has got 1, 2, 3, 4, 5, 6, 7 different sections to it. 7 different sections. Now let's have a look at what these different lines might mean. So the first line here, A to B, well, that's moving away from the start at steady speed. Okay, it's a straight diagonal line, which means steady speed. The second section of the graph is doing the same thing, but it's steeper. It's much steeper. So therefore it has a bigger speed. Okay, the steeper the gradient, the bigger the speed. But it's still moving at constant speed, it's still moving away from the start. Then we come to section C to D, and the line goes flat. We know that that means it's stationary for a short time. Okay, the next section is D to E, and we can see that it's now moving away again at steady speed, away from the start. Okay, next section, E to F, well, it's flat again, and we know that that means it's stationary, it's not moving. Okay, something different starts to happen now as we come from F to G. The line is going down. It's a straight line, so it's steady speed, but it means it's coming back towards the start again. Okay, coming back towards the start. And the final section down here, I'm going to do that in red, is quite a steep section, so it's traveling very quickly, and it's still coming back towards the start because the line is going downwards. Now what you will need to do next is to review this PowerPoint and just make sure that you're happy with all the ideas, and then I want you to try and do the mini quiz, and the mini quiz will ask you some questions about these graphs again. Okay, so it's not a big test, just a few questions about these graphs to see have you understood the key ideas. Good luck.